after the least squares regression line. So for this one, we are going to need to firstly put the data that we've been given into our graphical calculator. So once you've got your data into your calculator, it's important to stress at this moment that you do need to make sure you've checked it so that you've got the information right, because at this stage we're going to be looking for 4 marks here, and if you just make one little error, one slip of numbers going in, you won't get any if you have made a mistake here. So we go into calculate mode and we're going to do the regression line. Now when I press X, it goes straight into the answer, whereas you get 2 options for AX plus B and A plus BX. It won't actually matter which one you use. So I've got, just as I said, no option, so it's Y equals AX plus B. So this means that my least squares regression line is going to be of the form Y equals, so what A is 3, and I think looking at that number, clearly the exam board wanted it to be 3 exactly, so I'm going to use it as 3 exactly, so 3x plus 181.3. Okay, so that's my A term and my B term. So that gives me my equation by straight line that links what's the context here? The mass of a compound dissolved in 100 millilitres of water at different temperatures. So now I've been asked to interpret in context the value of the gradient for my regression line. So that's part A. For part B then, so the gradient is equal to 3. So what this means is that for every 1 unit increase in x, y is going to be increased by 3. Okay, so we're going to state that for every 1 degree centigrade increase in temperature, then another 3 grams of the compound will dissolve. Will dissolve. So, and that's what we mean by context. We need it actually in terms of what's going on in the question. So for every time that x gets 1 degree higher, 3 more grams on average will be dissolved of the compound. So if we're looking, say we just take this one here and just see what's going on, the temperature increase was 5 degrees and another 15 grams, so 3 lots of 5 dissolved. So it does make sense in some of the context. I've picked one that does exactly illustrate the point. Now for part C, use your equation to estimate the mass of the compound which will dissolve. I don't think any students got this one wrong unless they didn't get the original graph. So line equation. So it's y equals 3 lots. Now the temperature is 68 plus the 181.3. So if we just grab our normal calculator, we're just going to do 3 lots of the 68 plus 181.3. So we end up with 385.3. So y equals 385.3, and that's grams, because that's how much compound is going to dissolve in 68 degrees centigrade. Now part D, given that the values of the 12 residuals on the regression line y on x lie between -7 and 9, comment with justification on the accuracy of the estimate. Now the range of the residuals is the difference between those two numbers. So the range of the residuals in this case is 16. Now looking at the y values, we need to compare 16 with those y values, because that's what the residual is. It's the difference between the actual number and the number if we were to read it straight from the line of best fit from this equation here. Now because the range is only 16, that means that in all likelihood we are closer, we are at most 16 off effectively our correct line. So the range of the values is 16. So for my solution for D, I would write residuals are quite small, the range is 16 compared to the data, so the estimate is likely to be accurate. So the range is 16, which is small compared to the data. We often talk about being less than 10%. Yeah, so 10%, if any of these data items were 160, then the range of the residual would be exactly 10% of it. If it's less than 10%, we're saying that it's small compared to the data, and therefore the conclusion, so my estimate, is likely to be accurate. If the residuals were large, then what that would be telling us is that the distance between the observed value and the predicted value is quite big, and therefore the estimate would be less accurate. But in this case, the residuals are small, the range is small compared to the numbers, so our estimates are likely to be accurate.